Okay, so for number 14, we have a list and they say compare these substances by comparing their polarity. Okay, they want to know what's the molecular polarity, and now they say that you need to look at the electronegativity numbers. But if a molecule is polar or non-polar, the best thing to look at is to check the symmetric lines. Now remember, they won't see what you're doing. Okay, so checking the symmetric lines and comparing the Lewis structures is easier than going to the electronegativity numbers. Remember, your electronegativity numbers you're going to look at for bonds. Okay, so that's your, if it's a different type of bond. So let's check. I already drew the molecules. This is now for question number 14. Carbon dioxide, ammonia, water, CH4, and then your N2. So looking at the symmetric lines, we can see that carbon dioxide is non-polar. Because we only have one symmetric line for ammonia, it's a polar molecule. Again, water, only one symmetric line, that's polar. Can you see that if you have no or one symmetric line, it's polar, and two or more, it's non-polar? Because your CH4 has 4 symmetric lines, and your nitrogen also, so those two are also non-polar molecules. So the only 2 polar molecules will then be, for question number 14, will be option C. Oh, that nobody can see that. Will be option C, where it's ammonia and water. Now to continue, we can go on to number 21, where they say compare the following: HCl, HBr, HF, and HI. Now its bonds with, and this is now for question number 21, HF, Cl, Br, and Hi, they're all in the same group on the periodic table. It's our halogens bound to a hydrogen. So you should immediately think, they say compare and look at what's the wrong statement. You should think at our night graph, where we have our boiling points in degrees Celsius over molecular mass. Now you should know that a HF, if you compare it to another HF, it will have a hydrogen bond. Okay, that's the intermolecular forces. Now remember, boiling points has to do with intermolecular forces, so between molecules. Okay, and all 3 of the next, HCl, HBr, and Hi, is polar molecules that has bonds to be dipole. Dipole, I'm just going to say dipole, dipole, intermolecular forces. And that is really weaker than our hydrogen bond. So that means HF will be this molecule, this will be HCl, HBr, and that will be Hi. Now why did HCl increase to Hi? That increase shows there's an increase in the molecular mass. Okay, so the stronger the intermolecular force, the stronger or the higher the boiling point, but the higher or the increase in the molecular mass, the increase in the boiling point as well. So if you look at question C, they want to know, compare these statements and which one is incorrect, which one is the wrong statement, and the correct option to have the wrong statement will be C, where we have that HF has the lowest boiling point, and that's not true, because A, B, and D are all correct statements if you go through them individually. Okay. Okay, so number 23, they just want to get there in my pages. Sorry. Number 23, they have, which statement is correct according to the different forces that we have in water and HCl. So here's water and HCl. So here you just need to know what's the differences here. So what is that and that and that? So we have different forces over here. So you should know that a bond or a force that we get between this is one molecule and that is another, you should know that the force between them is an interforce, okay? But a force that we get inside, I taught you we need to speak like we're from Boys High, inside. So here, that force and that force over there is then our intra-forces, intramolecular forces, okay? So which statement is then correct? We want to know, they said that this is X, and they said that that is Y. So we now know that X is an intermolecular force and Y is an intramolecular force. So the correct, for number 23, the correct statement will be statement B. That was for number 23. If we now go to question number 34, they give us a list of molecules and they want to know which one is the correct Lewis diagram for molecule Ni3. So let's quickly just go through how to draw a Lewis diagram again. So we're comparing the valence electrons, which is the outer shell electrons. So we need to go and look at the group number because your group number directly correlates your valence electrons. So this is a group 5 element and a group 7 element, but we have 3 of them, so that is a total of 721 plus 5, so that's 26 electrons, meaning we have 13 pairs. Then remember, your molecule with the lowest electronegativity will be in the middle, but this will also not make sense that we will have 3 iodides in the middle. And then we just pack the electrons first between the different bonds, and then you're going to octet the outside elements. So we have 3 pairs already, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So all the outside elements are happy, but remember, elements bind so that they will fill the octet. Nitrogen is not happy yet, but we have one extra pair left, so it is that one. So the correct Lewis structure for Ni3 will be Lewis structure D. To go on to number 35, you'll see with number 35, they gave you a list, which is here on number 35. They gave you this list, NH3, F2, CCl4, and then H2O, and they want to know which one has a non-polar bond. So now we're looking at the electronegativity changes. Okay, so which one is a non-polar bond? So you're going to look at the different electronegativities. You should know, or you can look it up as well, but that nitrogen is 3.0, that is 2.1. So we have an electronegativity change of 0.9, I think. Fluorine is 4.0 and 4.0, so the electronegativity is 0, and that's your correct answer actually, number B. Because to have a nonpolar bond, we need to have a difference in electronegativity from 0 to 0.4, that's nonpolar. For polar, it should be anything from 0.4 to 1.9. Some textbooks say 2.1. Okay, oh, that's 1.9, sorry. And then anything above it is then ionic. Okay, so let's just continue for practice sake. Carbon is 2.5, chlorine is 3.0, so that's a 0.5 electronegativity. So that's a small polar bond. And then 2.1 and 3.5, I think it's 1.4, I think. But the correct answer for a non-polar bond will be fluorine. Okay. And then your last question on intermolecular forces will be question number 36, where we're just going to compare Lewis diagrams, Vesper forms, and then polarity of a molecule that they gave us to be number 36 to be SF2. So S is in group 6. For the Lewis diagram, again, we're looking at the valence electrons. Fluorine is in 7, but we have 2 of them, so it's 14 plus 6, which is Just want to make sure, yes, it's 20. 20 electrons giving us 10 pairs. S has the lowest electron negativity, it's 3 or 3.5, and fluorine is 4, and then we just pack it around. Again, bonds first, then we octet the outside. So there's 4, 5, 6, 7, and 8 pairs, and then just to make sure that S is happy, we put the lone pairs on the central atom. But that is not the Vesper form. The correct Vesper form I'm going to put there on the next slide is S, and S with its 2 lone pairs of electrons, and F again. So that, because of that lone pairs that we saw here on the Lewis, it's pushing down the bonds. It's making an angular Vesper form because of those lone pairs. All right? And obviously, because now if we look at the symmetric lines, we can see there's only one symmetric line. So this is a very much so, not non-polar, but a polar molecule. And then your correct option will be option B from that table that says the correct Lewis is given to be sketch B. Sketch B is your correct one. It is angular and it is polar. And that is your section on intermolecular forces.